Students, we are discussing mineral nutrition, right? Mineral nutrition, right? Now listen here. Based on diverse functions, different functions performed by essential elements. Essential elements are classified into four broad categories. Right? Based on diverse functions. Based on diverse functions. Based on diverse functions of essential elements. Based on diverse functions of essential elements. Essential elements. Essential elements. Essential elements are classified. Essential elements are classified into four broad categories. Classified into four broad categories. Is this statement okay? Right. Sir, based on what, sir? Based on diverse functions. What are classified? Essential elements are classified into how many broad categories, sir? Four broad categories. Okay. Sir, what are these four broad categories, sir? Number one, go for the first one. Essential elements. Essential elements which are components of biomolecules. What, sir? Essential elements. Essential elements. Essential elements which are essential elements which are what? Components. Which are components of biomolecules. Components of what, sir? Biomolecules. Sir, if they are components of biomolecules, then that elements will be structural elements of the cell. Yes or no? Hence what? Hence structural elements. Hence structural elements of the cell. Structural elements of the cell. Right? Sir, see this group. Sir, in this group, which essential elements are included, sir? Essential elements which are components of biomolecules. Essential elements which are components of biomolecules. It means which are structural elements of the cell. Such essential elements are included in this group, sir. For example, carbon, hydrogen, oxygen, nitrogen, etc. Therefore, under this group, write what elements we can place, sir? Carbon, hydrogen, oxygen, nitrogen, etc. Is it okay? Right. Now go for number 2. Now listen here. Essential elements which are components of energy-rich compounds. Components of energy-rich chemical compounds in a plant. Right? What is the second one, sir? Essential elements. Essential elements. Essential elements which are components. Which are components of energy-rich chemical compounds. Energy-rich chemical compounds in plants. Sir, in plants, you take any energy-rich chemical compound, sir. In that energy-rich chemical compounds, some essential elements are present as components. That essential elements which are present as components of energy-rich chemical compounds in a plant, they are placed in this group, sir. For example, take ATP. Sir, what is the full form of ATP, sir? Adenosine triphosphate. Yes or no? Triphosphate, phosphorus. Therefore, this phosphorus present in ATP, that phosphorus comes under, right, this group. Yes or no? Therefore, what's our phosphorus in ATP? Phosphorus in ATP. I am writing examples. Phosphorus in ATP. Sir, what is the central metal atom of chlorophyll, sir? Magnesium. What is the central metal atom? What is the central metal atom, right, of chlorophyll, sir? Magnesium. Therefore, this magnesium, which is a central metal atom in what, sir? Chlorophyll. Therefore, this magnesium, right, comes under this group, sir. Is it okay? Therefore, magnesium in chlorophyll. Sir, in chlorophyll, what is the central metal atom? Magnesium. That magnesium, which is present as a central metal atom of chlorophyll, magnesium, which is present as central metal atom of chlorophyll, that magnesium comes under this group. Is it okay? Right? Go for the next group, right? Essential elements which acts as activators or inhibitors of enzymes. What's essential elements? Essential elements which acts as activators or inhibitors. Activators or inhibitors of enzymes. Okay. Therefore, essential elements which acts as activators or inhibitors of enzymes, that essential elements comes under this group. Okay. For this group, I am writing some examples. Okay. Right. Essential elements. Activators of enzyme. Now see here, sir, essential element. Which essential element is activator, is acting as an activator of an enzyme? Okay, go for number one, first example, right? So take a magnesium. Sir, magnesium is a macro element. It is a macro element. Yes or no? Right? Sir, this magnesium, it acts as an activator of which enzyme, sir? Magnesium acts as an activator of number one. What's, sir? Hexokinase enzyme. Which enzyme it is? Hexokinase enzyme. Next one is Rubisco. What it is, sir? Rubisco. Right. And next one is pepcase. What it is, sir? Pepcase. C-A-S-E. Pepcase. Okay. Right. Sir, what is another name of this Rubisco, sir? Rubisco is also called as RUBP. Carboxylase oxygenase. What's that? Oxygenase. Carboxylase oxygenase. Right. Sir, this Rubisco is the most abundant protein. In first year we read, this is the most abundant protein in the plant kingdom, in the biosphere. Yes or no? Most abundant protein. Most abundant protein in plant kingdom. Most abundant protein in the plant kingdom. At the same time, it is the most abundant protein in the biosphere. Most abundant protein in the biosphere. Yes or no? Sir, this Rubisco, also called as RUBP carboxylase oxygenase. Okay, this Rubisco is the most abundant protein in the plant kingdom, is the most abundant protein in the biosphere. Okay, sir, PEP carboxylase. PEP case means nothing but PEP carboxylase. PEP carboxylase. PEP What, sir? Carboxylase, PEP, carboxylase. Is this statements okay? Right. Now listen this statement carefully. Sir, this Rubisco and PEP case, these two enzymes are used for carbon fixation, carbon dioxide fixation during photosynthesis. During photosynthesis, for fixing carbon or carbon dioxide, these two enzymes are utilized. What are the two enzyme names, sir? Rubisco and pepcase. I am not speaking about hexokinase. I am speaking about these two enzymes, right? Therefore, Rubisco and pepcase. Rubisco and pepcase. What is the function of these two, sir? Rubisco and pepcase, right, used for carbon or carbon dioxide fixation, carbon or carbon dioxide fixation, right, during photosynthesis process. Okay, therefore during photosynthesis process, carbon fixation, carbon dioxide fixation requires these two enzymes, that is Rubisco and pepcase. Okay, right. Now go for number 2, second example, manganese. Sir, manganese is a macro element or micro element, sir? It is a micro element. It's a micro element. Which element, sir? It is micro element. Sir, this manganese, it acts as an activator of which enzyme, sir? IAA oxidase. IAA oxidase. IAA oxidase, that is indole 3 acetic acid. Indole 3 acetic acid, a type of oxin. Yes or no? Right. Therefore, manganese, it is a micro element, acts as an activator of which enzyme, sir? IAA oxidase. IAA oxidase, right? Now go for the next one. What it is, sir? Iron. Sir, this iron is which element, sir? It is also a micro element. Iron is also a micro element. Sir, it is acting as an activator of which enzyme, sir? It acts as an activator. It acts as an activator of catalase. Catalase enzyme. Acts as an activator of which enzyme, sir? Catalase enzyme. Next, number 4. Go for number 4, nickel. Sir, this is a recently discovered enzyme. Yes or no? Nickel is the enzyme which is recently discovered. Sir, this is also a micro element. This is also a micro element. Yes or no? Sir, this nickel, it acts as an activator of which enzyme? Acts as an activator of urease enzyme. Acts as an activator of which enzymes are? Urease enzyme. Okay. Next, number 5. What it is? Molybdenum. Sir, this molybdenum is also which element, sir? It is also a micro element. It is also a micro element. Right. Sir, this molybdenum acts as an activator of which enzyme, sir? Acts as an activator of nitrogenase enzyme. Acts as an activator of nitrogenase enzyme. Nitrogenase is also called as dinitrogenase. Dinitrogenase. Sir, what is the use of this nitrogenase enzyme? This nitrogenase enzyme is used for nitrogen fixation. Yes or no? Nitrogenase enzyme used for nitrogen fixation. Used for what, sir? Used for nitrogen fixation. Which enzyme is used for nitrogen fixation, sir? Which enzyme? Nitrogenase enzyme, right? Now go for the next example. What it is? Zinc. Number 6, right? Number 6. What it is, sir? Zinc. Zn+2. Sir, this zinc, right, it acts as an activator of which enzyme, sir? Number 1, carboxypeptidase. What it is, sir? Carboxypeptidase. 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 It is a proteolytic enzyme. It is which enzyme, sir? I am speaking about carboxypeptidase. It is a proteolytic enzyme. Name itself indicates a proteolytic. It means breaks proteins. Proteolytic breaks proteins. Carboxypeptidase is a proteolytic enzyme. Sir, this zinc, it acts even as activator for carbonic anhydrase. Carbonic anhydrase. carbonic what sir? Anhydrase, carbonic anhydrase. Sir, it even acts as an activator for alcoholic dehydrogenase. What sir? Alcoholic dehydrogenase, alcoholic dehydrogenase. Therefore, for carboxypeptidase, carbonic anhydrase, right, alcoholic dehydrogenase, for these three enzymes, right, Zn plus 2 acts as an activator, Zn plus 2 acts as an activator, right. Therefore, till now we discussed activators, till now we discussed essential elements which acts as an activator of enzymes. Here we are not going to discuss about the inhibitors, okay. Therefore, essential elements which acts as activators or inhibitors of enzymes comes under one group, okay, right. Now listen this statement. Sir, nickel and molybdenum are involved in nitrogen metabolism, are involved in what sir? Nitrogen metabolism, involved in nitrogen metabolism. Sir, this nickel, it is activating which enzyme sir? Urease enzyme. That urease is the first crystallized enzyme. Urease, first crystallized enzyme. This is the first crystallized enzyme. Who sir? Urease, right. Next. Sir, you take right, sir, nickel, this is the recently discovered enzyme. Yes sir, recently discovered enzyme which is acting as an activator of nickel is a recently discovered right essential element. Nickel is a recently discovered essential element which is acting as an activator of urease enzyme, which is acting as an activator of urease enzyme. Sir, listen this statement. Microelements, the major role of microelements, the major role of microelements in living organisms is they act as cofactors of enzymes, acts as cofactors of enzymes. What's microelements? Sir, their major role, their what? Major role in living organisms is to act as a what sir? Cofactors, to act as cofactors of enzymes, to act as cofactors of what sir? Enzymes, cofactors of enzymes. Now listen this statement once. Sir, we are discussing about microelements. This statement is concerned to microelements. Sir, microelements, what is their major role in living organisms? These microelements, they act as cofactors of enzymes. There are some enzymes which requires a element, to activate the enzyme, In such cases, that element acts as a cofactor. Therefore, cofactor, what it is sir? Cofactor. What it is? Cofactor. Here, what is acting as a cofactor sir? Mineral elements acts as cofactors of enzymes. Mineral elements acts as cofactors of an enzyme. Is this statement okay? Sir, this cofactor is required for catalytic activity of an enzyme. If enzyme wants to convert substrate into product, it means to show its catalytic activity, enzyme requires a cofactor. Here, who is acting as a cofactor, sir? Microelements, right, acts as cofactors. I am not saying that only microelements will act as cofactors. What I am saying means the major role of microelements in living organisms is to act as cofactors for enzymes. Is this statement okay? Sir, what is a cofactor, sir? Cofactor means nothing but a substance which is required for catalytic activity of an enzyme. Without this substance, the enzyme cannot carry out its catalytic activity. Without this substance, that is cofactor, enzyme is unable to carry out its catalytic activity. Such substances are called as what, sir? Cofactors. These micro elements, their major role in living organisms is to act as cofactors of enzymes. Just now we discussed magnesium for hexokinase. Yes or no? Right? It means hexokinase enzyme requires magnesium for its catalytic activity. So magnesium becomes cofactor for hexokinase enzyme. Take Rubisco, take peptase. For Rubisco and peptase, magnesium is required. It means that magnesium acts as a cofactor. For what, sir? It acts as a cofactor. For what? For Rubisco enzyme and peptase enzyme. Go for the second example. Manganese acts as cofactor, activator. For which enzyme, sir? IAA oxidase enzyme. Take zinc, Zn+2. It acts as an activator, acts as a cofactor. For which enzymes? Carbonic anhydrase, carboxypeptidase, alcoholic dehydrogenase enzyme. Take nickel. It acts as a cofactor. It acts as an activator of which enzyme? Urease enzyme. Take iron. It acts as a cofactor, activator of which enzyme? Catalase enzyme. Molybdenum, cofactor for which enzyme? Nitrogenase enzyme. Is it okay? Right? Therefore, what is the major role of micro elements in living organisms, sir? To act as a cofactors of enzymes. To act as a cofactors of what, sir? Enzymes. Therefore, I think you got an idea about these three statements. Okay. Therefore, sir, nickel and molybdenum, they are involved in what, sir? They are involved in nitrogen metabolism. The first enzyme that was crystallized is urease. Okay. The major role of micro elements in living organisms is to act as cofactors of what, sir? Enzymes. Right. Now we are discussing four broad categories. Till now we completed three. Right. Now go for the fourth one. Essential elements which alters osmotic potential of the cell. What, sir? Essential elements. Essential elements which alters means change, right? Which alters what, sir? Osmotic. Which alters osmotic potential. Osmotic potential. Osmotic potential of the cell. Sir, the essential elements which can alter the osmotic potential of the cell, all that essential elements comes under this category, comes under this group. Okay. For example, you take potassium. What, sir? Potassium. Right. Sir, this potassium, plays an important role in opening and closing of stomata by altering the osmotic potential of the gut cells. It alters the osmotic potential of the gut cells. Alters osmotic potential of the gut cells. Who, sir? Potassium. Alters what? Osmotic potential. Alters osmotic potential. Osmotic potential of which cells, sir? Gut cells. And plays an important role. Plays an important role in opening and closing of stomata. Opening and closing of what, sir? Stomata. Sir, this potassium, it is a micro element or macro element, sir? It is a macro element. It's a macro element. Okay. Therefore, potassium, it is altering the osmotic potential of which cells, sir? Gut cells. By which opening and closing of stomata takes place. Therefore, potassium alters osmotic potential of gut cell and plays an important role in opening and closing of stomata. Plays an important role in opening and closing of stomata. These are four broad categories. Okay, based on diverse functions. Sir, based on diverse functions, essential elements are classified into four broad categories. Yes or no? Components of biomolecules, hence structural elements of the cell. Number 2, components of energy rich chemical compounds of a plant. Number 3, activators or inhibitors of enzymes. Number 4, elements which alters the osmotic potential of the cell. Sir, based on diverse functions, elements are classified. Essential elements are classified into how many categories, sir? 4 broad categories. In this classification, if you see, sir, magnesium, right, as a central metal atom of chlorophyll, it comes under what, sir? Energy rich chemical compounds in a plant. At the same time, it also acts as an activator. Magnesium acts as an activator of an enzyme. It means if essential elements are classified based on diverse functions, then essential element may come under more than one category. We are having 4 broad categories. Essential element may be placed under more than one category because this classification is based on different functions, diverse functions. You can take magnesium. Magnesium has came under, right, group in which right, essential elements are, right, components of energy rich chemical compounds in plant. Okay, at the same time the magnesium acts as an activator of enzyme also. Therefore, it is placed under more than one group. Therefore, if essential elements are classified based on diverse functions, a essential element may come under more than one category, more than one group. Okay, right? See, we are discussing some important statements in note, right? Number 1, see this diagram carefully. Sir, in this diagram, only the roots of the plant are immersed in the nutrient solution. Therefore, during hydroponics, only the roots of the plant are immersed in the nutrient solution, dipped in the nutrient solution. Sir, see this tube. See this tube. Sir, this tube is used to supply oxygen. To the roots of the plant. Okay, this tube is called as aerating tube. Sir, this aerating tube supplies oxygen to the roots of the plant. Now, take this one. Sir, this is a funnel. What it is, sir? Funnel. By using this funnel, right, nutrients and water are supplied to the roots of the plant. Therefore, this funnel supplies what and what? Water and nutrients to the root of the plant. Therefore, this diagram labelings are important. Should be careful. Okay. Number 2. Sir, go for this diagram, right, of hydrophonics. See this diagram carefully. Sir, in this diagram, from reservoir, from where, sir? From reservoir, the nutrient solution is going into a tube, then into one elevated tube. Yes or no? This is the elevated tube. Okay. Sir, from reservoir, the nutrient solution moves up to this elevated tube with the help of a pump, P-U-M-P, given in the diagram clearly. Therefore, from reservoir, the nutrient solution goes up to the elevated tube, right, with the help of a pump. Again, this nutrient solution returns into the reservoir. The nutrient solution returns into the reservoir under the influence of gravity. These 2 statements once asked in AFMC. Therefore, you should be careful with these statements. Therefore, I wrote the same statement here. See, sir, in hydroponics, right, with the help of a pump, the nutrient solution is moving from reservoir to elevated tube. Okay. Then again, the nutrient solution returns to the reservoir under the influence of what, sir? Gravity. Reservoir to elevated tube with the help of a pump, right? Again, the nutrient solution returns to reservoir under the influence of what, sir? Gravity, right? Number 2. Sir, during hydroponics, right, to maintain the mineral ions, in soluble state, we are adding, right, chelating agents or ligands. Number 2, what's are chelating agents or chelating agents? Chelating agents also called as ligands. Sir, what is the use of these chelating agents or ligands, sir? Right, this chelating agents or ligands, right, what they will do, sir? Maintains what? Mineral ions. Maintains mineral ions in nutrient solution. Maintains mineral ions in nutrient solution. In which state, sir? In soluble state. In which state, sir? Soluble state. Who is maintaining mineral ions in the nutrient medium in soluble state? These chelating agents are ligands. Sir, in hydrophonics technique, right, we are adding iron in the form of iron EDTA. Iron EDTA. Therefore, iron is added. Iron is added as iron EDTA. Why, sir? Because if iron is added as iron EDTA, right, it prevents precipitation of iron at alkaline pH. Prevents precipitation of iron at alkaline pH. Therefore, iron is added as iron EDTA, right, which prevents what's our precipitation, PPT, which prevents precipitation of what? Iron at which pH, sir? Alkaline pH. At which pH, sir? Alkaline pH. Right. Now see this statement. Listen this statement. Number 3. Go for number 3. Sir, during hydrophonics, the nutrient solution is covered with a black paper. Nutrient solution is covered with a black paper. Why, sir? Number 1, to minimize the interaction of sunlight with roots. It minimizes the interaction of sunlight with what, sir? Roots. Number 2, prevents contamination of nutrient medium with algae. Prevents contamination of nutrient medium with what, sir? Algae. Therefore, during hydrophonics, what, sir? During hydrophonics. During hydrophonics, right, nutrient medium. What, sir? Nutrient medium. Nutrient medium covered. Nutrient medium covered with a black paper. Nutrient medium is covered with a black paper, which what it does? Which minimizes. Which minimizes. What it minimizes? Number 1, interaction. Which minimizes interaction of roots with sunlight. Interaction of roots with what, sir? Interaction of roots with sunlight. Interaction of roots with sunlight. Okay, right. Number 2, second one, minimizes contamination. Minimizes contamination of nutrient medium. Contamination of nutrient medium by algae. Contamination of nutrient medium by algae, right? Now go for number 4. We are discussing statements in note, right? Sir, lettuce. Lettuce is a leafy vegetable. Leafy vegetable, right, belongs to Asteraceae family. Belongs to which family, sir? Asteraceae family. It's a leafy vegetable, belongs to Asteraceae family. Okay. Number 5, sir, sea lettuce. I already told this statement. Sir, sea lettuce means nothing but ulva. Ulva is a algal member, right? It is a algae. It's a algal member. It's algae, right? Next, number 6, protoplasmic elements. Protoplasmic elements. Which elements, sir? Protoplasmic elements. Sir, in protoplasm, in what sir? Protoplasm. In protoplasm, the main elements are, in protoplasm, the main elements are, what are the main elements in protoplasm, sir? Carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur. What sir? Carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur. All these are which elements, sir? They are macro elements. Yes or no? They are which elements, sir? Macro elements. This carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur, these are called as protoplasmic elements. What these are called as protoplasmic elements. Next, number 7, critical elements. What's a critical elements? Critical elements. Now listen here. In almost all types of soils, right, nitrogen, phosphorus and potassium are deficient. That's why these 3 elements are called as critical elements, right? In almost all types of soils, in almost all types of soils, nitrogen, phosphorus and potassium are deficient. Nitrogen, phosphorus, potassium are deficient. So nitrogen, phosphorus, potassium are which elements, sir? Critical elements. Which elements they are? Critical elements. Sir, listen this statement. Sir, nitrogen, phosphorus, potassium, they are deficient in the soil. Then how a plant gets these 3, sir? So a farmer should supply nitrogen, phosphorus and potassium in the form of fertilizers. In the form of what? Fertilizers, right? So nitrogen, phosphorus and potassium should be supplied to plant, in the form of what, sir? Fertilizers. Sir, how that fertilizers are named as, sir? 15 or 18, 17, right? 19. Sir, what are these numbers, sir? These are according to properties of NPK. It means how much nitrogen, how much phosphorus and how much potassium that is added. Nitrogen, phosphorus, potassium. Is this statement okay? Right? Now go for the next statement, right? Number 8. Sir, we are discussing some important statement in a right note, right? Sir, which elements are critical elements, sir? Nitrogen, phosphorus and potassium. These are which elements, sir? Critical elements. A plant never shows deficiency symptoms for carbon, hydrogen and oxygen. Plant never shows deficiency symptoms for carbon, hydrogen and oxygen. Why, sir? Because these 3 elements, they won't be deficient in plant at any time. What are the 3 elements? Carbon, hydrogen and oxygen. Therefore, carbon, hydrogen and oxygen. Plant never shows. Plant never shows what's deficiency symptoms. Plant never shows deficiency symptoms for carbon, hydrogen and oxygen. Why plant is not showing deficiency symptoms of carbon, hydrogen and oxygen? Because in a plant, these 3 elements, never they are deficient. They won't be deficient at any time. Which elements? Carbon, hydrogen and oxygen. So a plant never shows deficiency symptoms for carbon, hydrogen and oxygen. Right? Go for the last statement. Now listen this statement. Essential element. What's a essential element or macro element. Essential element or macro element required in large quantities required in large quantities for growth and development of plant. For growth and development. For growth and development of plant. See the statement? Sir, which essential element or which macro element a plant requires in large quantities, right? In largest quantities for growth and development of the plants are nitrogen. Therefore, which essential element or which macro element is required in largest quantities for growth and development of the plants are nitrogen. Number 10. Micro element. Micro element required. Micro element required in large quantities. Required in large quantities for growth and development of plant. For growth and development of plant. Sir, which micro element a plant requires in large quantities for growth and development of the plant, sir? It's iron. What it is, sir? It's iron. Okay, these are some important statements right concerned to hydroponics and essential elements, right? Thank you.